Hello guys, today we're going to be exploring a new category of something called Project Euler. It's a bunch of mathematical questions that you solve with coding that were made after this famous mathematician guy, and there's 800 plus questions, I think like around 850. And today I'm going to be showing you how me and my uncle solved question 1. So each question has multiple ways to solve it. This is how we solved the first one. So if this is the question right now, we've already done it, but I'm going to hide the answer until the end to see if it matches and show you guys. So first, here's the question. If we listed all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1000. So now we go into our code here. And first, we are going to use modulus to do so we can find out the multiples. And modulus, I'll show you how we'll use that right now. So I'm going to define it right now, define a function. NO, I like to because it stands for number, so I'll put that in there. Then colon, if in brackets, NO modulus, so NO, which is whatever number I like to put down, whatever number we do, divided by, modulus 3 equals 0 if it does. So if its modulus means it divides it by 3 and shows the remainder. So if the modulus by 3 equals 0, so if the remainder, when you do it, is 0, that means it's a multiple of 0. If it is that, return true, else return false. Now, I'll show you how it works. So if I do print multiples of 3, then in brackets, parenthesis, I do a random number, like 1. Then if it returns true, it is true. If it returns false, it is not a multiple of 3. So if I run it, it's false. It's not. Also, a quick way to check if a big number is a multiple of 3. This only works on 3, by the way, so don't do it with other numbers. If all the singular digits add up to a multiple of 3, then the whole thing is a multiple of 3. So 4 plus 5 plus 6, that would be 20. So no. But if I changed any of them, like this 5, for example, then it will be, because then they would add up to 21, which if I do that, it's true. So that's just a quick way to check with 3. So now I'll delete this, don't need that. So now I'll do another method for the multiples of 5, because we also need that. And basically it's the exact same as this one. So Control V, C, Control V. It's basically just the exact same, except I'm going to change the name and change the modulus. So that is the same thing, but with 5. So now we have both of these. And now it's time to put both of these into something bigger. So these two things are just parts for a bigger one. And we're going to define multiples of 3, 5. Then in there I'm going to put sum. I'm going to put sum, actually not that, I'm going to put capital. I'll put there, then, oh, no, sorry. Multiples of 3, sum, or multiples of 5. Sum. And then, actually I'm not going to put that, I'm going to put in if in front of that. Forgot the if. If sum return false or true, until else return false. So basically now this is just both of them. So if it was a multiple of 3 or 5, it would be true. So now there is more chance for it to be true with the numbers. So now we're going to move on to the final step with the last bit or section. I'm going to do for the final step, sum counter equals 0. I'm going to do a counter. Then I'm going to do for and all in range 1000. If multiples 3 and 5 and all sum counter plus equals, which is basically saying sum count plus equals NO, which is basically saying, which is the short version of sum counter plus NO. And you can just do plus equals like that. So now, click off that. Final thing, print sum counter. Oh, sorry. Sum counter. Now this is the NO in range 1000. If not a NO, sum counter. So basically, this in the for loop, it keeps looping, and if the multiples of 3 or 5, the NO here and here, in range 1000, in the numbers 1000, if it picks up anything, remember this 3 or 5, you don't need to write more code because all of this is packed into this function. So we don't need to even write it. All of these up here, these are just functions that are all part of the final line of code, and this bit has all of these inside of it, so that alone does all of this. So now in range 1 this in the for loop, as I was saying, it goes, and every time it's a number that is a multiple of 3 or 5, it will add to sum counter. So in the end, we'll get this. If I save that and run it, get that. And remember these numbers: 233, 168, 233, 168. Now, if we go here to project Euler, 233, 168. That's the answer. So thank you for watching. Hope you learned how one way to do this. If you've done it in a different way, please share your message in the comments, and see you next time.